Welcome back to TechSpectrumPro. Today, we delve deeper into the realm of network security with access control lists, or ACLs. You might be wondering, what exactly are ACLs? Simply put, ACLs are an integral component of network security that governs the traffic flowing into and out of a network. They act like a gatekeeper, deciding which data packets to allow through and which to deny, based on certain rule sets. This is crucial in ensuring the smooth running of a network system. By controlling access, ACLs prevent unauthorized users from infiltrating the network, thereby protecting sensitive data and maintaining system integrity. They also manage network traffic, reducing unnecessary load and improving overall performance. So ACLs are not just about security, they also play a pivotal role in network efficiency. Understanding and implementing them correctly can significantly enhance your network's functionality. So now that we understand what ACLs are and why they're crucial, we can move on to understanding their advanced configurations. Before we dive into the advanced configurations, it's essential to have a clear understanding of the basics. Access control lists, commonly known as ACLs, are a fundamental part of network security. They provide a means to filter and control traffic in a network. By defining a set of rules, ACLs decide which traffic is allowed or denied into or out of a network, or even within a network. One of the significant aspects of ACLs is their versatility. They can be applied to various interfaces and directions. You can implement them on the inbound or outbound traffic of an interface. When an ACL is applied to inbound traffic, it filters the traffic before it enters the network or a device. On the other hand, when it's applied to outbound traffic, the traffic is filtered after it has passed through the device. The operation of ACLs is straightforward. They sequentially evaluate the packets against the conditions defined in the ACL. The first match determines the fate of the packet. If it matches the permit condition, the packet is allowed. If it matches the deny condition, the packet is dropped. This sequential evaluation continues until a match is found. If no match is found, an implicit deny clause at the end of each ACL drops the packet. Another fundamental aspect of ACLs is their effect on the network traffic. They provide granular control over network traffic. You can filter traffic based on several parameters, such as source IP, destination IP, protocol, and even port numbers. This level of control helps in enhancing the network security by allowing only the necessary traffic and blocking the unwanted or potentially harmful traffic. ACLs also play a significant role in quality of service, or QoS, and network address translation, NAT. They help in identifying and classifying traffic for QoS policies and in defining which IP addresses are translated in NAT. With these basics fresh in our minds, we are now equipped to tackle the advanced configurations. Now, we dive into the first part of our advanced ACL configurations. Access control lists, or ACLs, are a fundamental aspect of network security, allowing us to control traffic and protect our network from threats. But to truly harness their power, we must delve into the realm of advanced configurations. One such configuration we'll discuss today is the Extended Access Control List. Unlike their standard counterparts, extended ACLs offer a more granular level of control. Standard ACLs operate by checking the source IP address of the packet alone. In contrast, extended ACLs expand upon this by not only examining the source IP address, but also the destination IP address, the type of protocol used, and even specific port numbers. This increased level of detail enables us to create more tailored security measures. For instance, we can configure an extended ACL to permit or deny traffic from a specific source IP to a specific destination IP using a specific protocol and even on a specific port number. This flexibility is particularly useful in complex network environments where we need to control traffic on a more detailed level. Another advantage of extended ACLs is their ability to filter traffic based on both TCP and UDP protocols. This is particularly beneficial for applications that use specific ports, such as web servers or email servers. By specifying the protocol and port number, we can ensure that only the appropriate traffic reaches these sensitive applications, thereby enhancing our network's overall security. Additionally, extended ACLs can be applied to both inbound and outbound interfaces, offering us another layer of flexibility. This means we can control traffic coming into a network, going out of a network, or both, depending on our specific needs. In essence, extended ACLs provide us with a more nuanced approach to network security, allowing us to control traffic with greater precision and flexibility than standard ACLs. That concludes the first part of our advanced configurations. Let's move on to the next. Continuing with our exploration of advanced ACL configurations, let's delve into the second set of advanced configurations, particularly focusing on reflexive access control lists and their crucial role in network security. Reflexive ACLs, also known as IP session filters, are a fantastic way to add an extra layer of security to your network. They are dynamic and temporary in nature, created in response to outbound sessions and applied to inbound traffic. They keep an eye on the IP sessions, tracking the source and destination IP addresses, port numbers, and the protocol being used. The beauty of reflexive ACLs lies in their ability to reflect the outbound sessions and apply the same rules to the incoming traffic. This means that if an outbound session is initiated from within your network, only the return traffic for that specific session is allowed back in. All other unsolicited inbound traffic is blocked, significantly reducing the risk of attacks. Creating a reflexive ACL involves three main steps. First, an access list is defined for outbound traffic. This list includes a reflexive ACL that logs session information. Second, the outbound access list is applied to the outbound interface. Lastly, an inbound access list is defined to allow only return traffic from the outbound sessions. Remember, reflexive ACLs are not a standalone security solution, but rather an additional tool to enhance your network security. They work best when paired with other security measures such as firewalls and intrusion detection systems. It's also essential to note that reflexive ACLs require careful handling. Since they are temporary and dynamic, a sudden surge in outbound sessions could potentially overwhelm the router, leading to performance issues. Therefore, monitoring and managing your network traffic is key when implementing reflexive ACLs. With that, we've covered the second part of our advanced configurations. We've learned about reflexive ACLs, how they work, and their role in enhancing network security. In the next part, we'll explore more advanced ACL configurations, so stay tuned. We're now onto the final part of our advanced ACL configurations. In this segment of our discussion, we're going to delve into the last set of advanced configurations, focusing particularly on time-based access control lists, or ACLs, as they are commonly known. The thing about time-based ACLs that makes them so fascinating and useful is their ability to provide a level of control that is both detailed and flexible. So, what exactly is a time-based ACL? It's an ACL that operates according to a predetermined schedule. In other words, it's a tool that allows network administrators to control traffic flow based on the time of day or even specific days of the week. Imagine being able to limit certain types of network traffic during peak business hours to ensure optimal performance, or to schedule maintenance tasks during off-peak hours to minimize disruption. That's the power of time-based ACLs. Now, configuring time-based ACLs involves a couple of steps. First, you need to create a time range. This is where you define the specific time period during which the ACL will be active. Next, you incorporate this time range into your ACL configuration. It's important to remember that the ACL will only have effect during the defined time range. Outside of this period, the ACL essentially becomes a non-entity. The beauty of time-based ACLs is that they offer a level of granularity that's hard to beat. They allow you to control not just what traffic is allowed through your network, but when it's allowed. This can be a potent tool for optimizing network performance, managing bandwidth, and maintaining security. Of course, like any tool, time-based ACLs are most effective when used correctly. They require careful planning and thoughtful implementation. But when used properly, they can provide an extra layer of control that can make a significant difference to your network operations. And with that, we've covered all our advanced ACL configurations. And there you have it, an in-depth look at access control lists and their advanced configurations. We started off with a basic review, refreshing our understanding of ACLs and their role in network security. We then dove deeper into this subject, exploring the intricacies of advanced configurations. We've seen how these configurations can be tailored to meet specific network needs, offering a level of control and security that's both flexible and robust. From understanding how to set up complex ACL rules to knowing how to troubleshoot potential issues, we've covered a vast expanse of knowledge in this episode. We hope this deeper understanding of ACLs will enable you to create more secure, efficient, and reliable networks. Remember, mastering these concepts is not just about passing the CCNA exam, but about becoming a better network engineer overall. Thank you for joining us on this journey through ACLs. Stay tuned for more episodes on TechSpectrum Pro, where we keep you updated with the latest in technical training.